Yeah, fine, fine. Nice to see you.
Yeah, after a long time, quite many years.
Yeah, many months,
Yes,
not many years, many months.
been a couple of years, I think, 2024, maybe.
I think last year we must have met. No,
Right. I wasn't actually last entire, I think 9 months in the last year. I was not, I was kind of
I
traveling
said,
across.
okay, okay.
But,
Yeah, okay.
but
Maybe
irrespective,
before that.
yeah, yeah, yeah. Good to see you. Good to see you.
Yeah.
Hello.
Hello.
Okay, good afternoon, everybody. And a very warm welcome to all of you. On behalf of IEQ Ecospaces, I'm delighted to welcome you to today's knowledge series webinar titled Breathe Better Indoors, Fresh Air Ventilation and Indoor Environmental Quality Explained. My name is Lekha Khernar and I will be your moderator for today's session. As we spend nearly 90% of our time indoors, the quality of the air we breathe inside buildings has a profound impact on our health, comfort, productivity, and the well-being. Yet, ventilation and indoor air quality are often overlooked during design and operation of the buildings. Today's webinar brings together experts from the fields of sustainability, HVAC, engineering, and indoor air quality solutions to help us understand how thoughtful design and technology can create healthier indoor environments. We also have a short question and answer session at the end. So we encourage you to post your questions in the chat box during the session. Now we can begin with the opening remarks and overview by Dr. Roshni Uddavar Yehuda, CEO of IO Ecospaces LLP. Dr. Roshni Uddavar Yehuda is a leading sustainability consultant and green building expert with extensive experience in green building certifications, sustainable design strategies, and environmental consulting. Under her leadership, IOA Ecospaces has contributed to several projects that focus on energy efficiency, water conservation, and indoor air quality and sustainable development. She will now set the context for today's discussion and share insights on why indoor air quality and fresh air ventilation are critical in modern buildings. Roshni ma'am, you can take up from now. Thank you.
Thank you, Lekha. Good evening, everyone. I welcome all the speakers and experts of today and also all the participants. Thank you for joining. As you know, this is organized as part of our knowledge series, which we started quite some time back, but then there was a gap in the execution and we didn't have many webinars, but we are committed to spreading knowledge in this area of environmental architecture and built environment, how it can be made better. So today's subject, as Lekha has mentioned, is breathe better indoors. So it is very ironic that we have to conduct a webinar, or we are conducting a webinar on fresh air, something that is so essential to everyone that we literally cannot live without it. Yet the reason for organizing this webinar is precisely that. In the past 2 years or so, we have observed that in building after building, where either our team was involved as architects or green building consultants, or even people who came to us for advice, the building professionals and the management and the people involved had to be explained and convinced about providing fresh air inputs in their building. Now, that is really something, because as I said, it is really essential. And the reasoning that we were given is that it's not really essential. It will just add to the cost. And, we do have fresh air coming in through infiltration and so on. We can open the windows and so on. And that is true because in India, buildings are generally naturally ventilated and have, this concept, this myth is because of this that we have provision for fresh air when needed. And yes, for thousands of years, we lived in traditional buildings where, and climate responsive buildings where our traditional, maybe we can say Vastu Shastra, it did ensure that the building is properly oriented to catch the wind, and we did have fresh air, and fresh air was never a. However, the reality of buildings today is that with air conditioning, most window openings are not opened at all, and in many cases are not even openable. And we literally spend, as Lekha said, 90% of our time either in offices or homes where we do not open the window. And we have a good thermal comfort, we have good cooling, noise-free, dust-free indoor environment. But we are missing out on something essential, that is fresh air, and that is preferably treated. Now, unitary air conditioning systems, that is split window ACs, they do not have provision for fresh air, and the same air is circulated throughout the day. The National Building Code specifies in its chapter on natural ventilation specific air changes per hour for different spaces, ranging from say 2 to 4 for bedrooms, 6 to 8 for bathrooms, and so on. And for maybe something like cinema halls, it is much more. Internationally, also there are ASHRAE and other standards in place for fresh air. Where the problem is even more further multiplied is when workspaces are occupied to the brim or have more occupancy per square meter than what the standards prescribe. And in such spaces with no fresh air, transmission of diseases become easy, carbon dioxide levels increase within these spaces, and things like common cold, influenza, and other respiratory diseases spread rapidly, which further, affect the productivity of the people, cause stress, and ultimately long-term damage to the occupants as well as the owners. So these are the issues. And another common myth is that air conditioning protects us from dust and pollution outside. Now, it may appear so, yes, most of the particulate matter and gases in the outdoor environment are somehow able to enter the building through infiltration, and then they remain there unless the windows are open on a regular basis, or we are able to use some kind of a treatment unit, fresh air treatment unit, or we are able to flush out, through some kind of mechanically or natural ventilation. So this is the case. So in fact, the indoor environment is in fact more polluted than the outdoor. I can just go on and on based on all our experiences, but we have an interesting line of speakers who will not only describe the problem to you, but also provide the meaningful solutions, which is our intention. And so with that, I would like to close my introduction and let you all enjoy this informative webinar. Thank you once again for joining us.
Thank you, Roshni ma'am, for that insightful overview and setting the stage for today's discussions. Before we start the session, please be informed that if you have any questions, you can put in the chat box. It will be addressed at the end of each session. So our first speaker for today is Mr. Gautam Baliga, Director at Opal HVAC Engineers Private Limited. So Mr. Gautam Baliga is a mechanical engineering graduate from the IIT Technology Kharagpur. Before he began his career with Voltus and then later served as a partner director at Opal HVAC Engineers Private Limited, Mumbai, and RS Kulkarni HVAC Consulting Engineers, Pune. He's a fellow of ISHRAE. He has held several leadership roles, including the chairman of ISHRAE Institute of Excellence, chairman of the certification program, and president of ISHRAE Mumbai chapter. And he is also the publisher of ISHRAE Journal. He currently chairs the healthcare technical group at ISHRAE and is a member of ASHRAE, the Indoor Environmental Quality Global Alliance, and the World Health Organization Expert Advisory Panel on Indoor Air Quality. Today, he will share his insights on fresh air ventilation systems, practical design, approaches, and the role of HVAC in maintaining healthy indoor environments. Sir, we look forward to your talk. Thank you.
Thank you for that introduction, Lekha. Um, I appreciate Dr. Roshni for organizing these informative lecture series. And especially in today's context, we are talking about IEQ, which is at the heart of what I do day in and day out. So when we think about buildings, we often focus about how they look, the architecture, the material, or the design. But the true impact of any building would not be just visual, it is also experiential. This is where indoor environmental quality, that is IEQ, comes into picture. IEQ essentially is about how a building makes you feel when you occupy it, whether you feel comfortable, healthy, and productive, or otherwise. So, at its core, IEQ has got a few critical factors. I'll be talking only about what is my domain knowledge, and that's fresh air, moisture control, and proper filtration. When these three elements are properly managed, many indoor environmental problems can be minimized or even eliminated. In this talk, we will explore how controlling these factors can significantly improve indoor comfort, health, and overall building performance. So, with this, let me start the presentation. You have to allow me to share the presentation, Lekha.
Yes, sir, allow.
Can you see my presentation?
Yes, sir.
Okay. So, this is what we will talk about in this particular lecture, that is the fresh air, moisture, and filtration. If these three are controlled, then most of the IEQ problems will definitely disappear. So when air doesn't move, what happens? Basically, what you get is stale air, and then there is a buildup of carbon dioxide, and others don't go away. So the place becomes quite difficult to be in. So if you see this particular, picture, you find that there is air movement, some ventilation coming from outside, that blue arrow, and it's short cycling and going to the, left. There are portions in this particular room which have no air movement as such, and that's where the air is still. And what you will have is people looking tired out there. CO2 will build up, and others will remain inside the room in this particular case. Whereas if you look at this particular picture, you will find that the air is moving, all over the room. So you can see that the fresh air is getting in and going out. There's a cross ventilation, and you'll always have, in this kind of situation, smiling people and things like that. So we'll talk a little bit about CO2. We say that CO2 levels are high. How really it impacts? So CO2 is not really a pollutant. It is an indicator of ventilation per person. So if you look at this chart, we'll try to look at, correlate it with stale air. So if you say that CO2 ppm is so and so, we'll try to relate it to how many breaths of others that you're taking in into your own breath. That's a way of visualizing it. So if you say, for example, the indoor ppm is 500, It's like 1 in 475 breaths belongs to somebody else and that you are breathing. Same way, if the ppm is 2000, which is pretty high, it means that 1 in 24 breaths belongs to somebody else. Somebody else has exhaled that breath and you're breathing in. So that's pretty bad. So if you come to 5000 ppm, it means that 1 in every 8 breath belongs to somebody else. So that should make you quite concerned, because when you breathe somebody else's breath, you're breathing the infections that that person might have. So all sorts of other related issues come up. So let's talk a little more about this 500 ppm. You can see this is a classroom where 500 ppm is there. It's because there is adequate fresh air. 1 in 475 breaths are rebreathed, which is not too bad. People remain alert and comfortable. As against that, if you say in this classroom that the ppm is 2000, CO2 ppm is 2000. So the shared breath is 1 in 24. You can see that, the students are feeling sleepy. It's nothing to do with the academics part of it. It's more to do with the air, and they feel, don't feel like studying in this particular atmosphere. Look at this particular case. This is an auditorium. This quite often happens in most of the auditoriums where, the fresh air is not adequate, and 1 in 8 breaths is somebody else when, the recorded ppm is 5000. If you think that it is very unlikely, 5000 is very commonplace in most auditoriums. And these places are poorly ventilated. 1 in 8 breaths is somebody else's, and you have a headache. You can see, some of these people, you can see this, sorry, you can see this lady with the hand, at the forehead. It's not necessarily because of the performance, it could be because of the, air she is breathing. Now we come to a particular concept called zone air distribution effectiveness. Suppose you have got an air conditioned space. So you can see that the air is moving all over the place, but there are some places where it's not reaching. So there it manifests that as a hot place. It also manifests as a place where CO2 buildup is likely. So we have a term called EZ, that is your effectiveness. You can see this EZ is effectiveness. So what it means is that if it is very effective, the same air can do more job. That's the concept. So if you see this, when ventilation is more effective, EZ is more, and you require less clean air to do the same job. Vice versa, when the ventilation is less effective, that means it's not reaching many places, then you need more clean air to do the same job. So that ultimately, after a lot of circulation, something percolates into that area. So EZ is a very important factor when you are designing any particular room in terms of air conditioning. A good way of looking at it is with this particular, with these people sitting there, you can see that air is passing all over the place. Each one of the three inhabitants out here are getting, replacement air. So they look quite happy. Now here, it's an average air distribution. You can see that uh, here, it's bypassing to certain extent. Someone is not getting adequate air and so on. So there are some stagnation areas. And then we have got another case, sorry, where EZ is zero 0.5, which is pretty poor. The air conditioning air is there, but it's all bypassing most of the time. And these people are not too happy about it. So this is what happens. So if you were to look at it, it is more like, same quantity of air, the results are different because the air distribution makes a lot of difference. So if you say high effectiveness is equal to 1, you'll have low CO2, low moisture, low energy. Why low energy? If you require less air to fresh air to do the same job, you're consuming less energy. That's why. Then medium is Z equal to zero point 0.8. So uneven comfort, local CO2 rise. And the last case is low effectiveness, high CO2, moisture buildup is there. And it's not just restricted to that. When moisture buildup is there, there is going to be a mold risk. So if you were to, have a quantitative analysis of how much fresh air is required in a particular space, there are two ASHRAE standards which specify that. One is ASHRAE 62.2, 2022 is the latest edition. It is ventilation and acceptable indoor air quality in residential buildings. So when you say ventilation is how much of the air is fresh air. Recirculated air is not ventilation. It is how much of the fresh air is to be brought into the area. That's called ventilation. The other standard is 62.1, 2025. This is ventilation and acceptable indoor air quality for all other buildings. The first one was for residential buildings. This is for all other buildings. If you just have, there are scores of such pages in that, which actually tells you for each type of area, you think of the area, you'll find it in this particular handbook. It will say, for example, here you say that, how much CFM per person is required in terms of outdoor air and how much CFM per square feet is required of outdoor air. So, for example, if you have got a break room as is shown out here and it is 100 square feet, then and in that there are 10 people. So 10 into 5, 50 CFM is required for that room in terms of number of people, and 100 square feet into 0.06. That makes it, I think, 0.06 into 100, that is 6 CFM. So 6 plus 50, you need to give 56 CFM for this particular room. Otherwise, the room will feel stale. And this, of course, assumes that your effectiveness is 1. So if your effectiveness is 0.5, just for argument's sake, that 56 divided by 0.5, you'll have to give 112 CFM as against 56 for a well-designed air conditioning system. I hope you get that point. Now we come to another aspect, that is moisture. Moisture is invisible and it comes from all over the places. It could be from leakages from your external wall. It could be due to condensation of some pipes. And what happens is whenever there is a condensation of water anywhere, the mold starts growing. And once it starts growing, you'll have to have some positive methods of stopping it. Otherwise, it won't keep, it will only keep growing. That's all. So it's really quite a big problem. So you just see what this slide says is, fungi such as mold and mildew are everywhere. Then fungal spores are extremely common in the air with outdoor concentrations typically ranging from 200 to 1 million spores per cubic meter. Even as wherever you are and you are breathing the air, you could be having any of these type of numbers. What is important is that the spores that you are breathing should not be toxic. That's more important. You can't have a place where there are no fungal spores. Then indoor ducts, the air conditioning ducts. If you were to, scrape the ducts from inside, you will find that 1 to 2 million spores per milligram of dust is there. So the indoor ducts are quite, dangerous places, and people who clean them are subject to, all sorts of infections, unless they, of course, take precautions. Now, how does mold grow? Basically, you need four elements. There has to be a viable spore. It's like a seed. There has to be food source. Without food, it's not going to grow. Then the temperature has to be suitable, and there has to be moisture in the food source. The most important thing is, without the moisture, there is no way that viable spore can access uh, the food in the moisture, in the food source. It is the moisture that breaks down the enzymes in order for the viable spore to be able to access the food. These are some of the dangerous fungi that are associated with the air conditioning systems. First is this aspergillus on the damp wall. Where does it come from? Basically, people, the origins are basically in the soil or decaying plants. So when you go through a garden or some such place, these aspergillus fungus are out there, and they cling on to your clothes, and then you come home or you go to office, and then it circulates in the air, and then it finds its place on some damp spot on the wall. So this is your aspergillus. It's quite common. Next is penicillium. It is on food items that are kept inside the inside the spaces, and after some time they catch fungus. And this is a very common site. This is cladosporium that gets deposited on diffusers. If you see these green spots, it's not really dust, it's fungus. And this is very common in air conditioning ducts, which have not been designed properly. And this is Tachybotry's chartanum on damp walls. If you scrape off the plaster of Paris or gypboard on your wall, and if the wall happens to be a wet wall, Stachybotry chartanum starts growing, and it's pretty toxic. So people with allergies can be really at risk when these sort of fungi are around. So basically, when the area has got a temperature which, encourages this kind of dew formation, the condensation is there, then the mold problem starts. It starts when, moisture comes in through the external walls, as is shown out here. And you get this fungus, mold, and all that on the walls. And basically, just to give an idea how big is this problem, let's talk of a fungus, Aspergillus fungus, which is fumigatus, particular category. Mold growth in 100 days is at 1 mm per day when the RH is more than 85%. So if you have a mold which was initially 1 mm, you can expect it to be 100 mm at the end of 100 days. So if you're looking at it after a year, you can guess, you can do the maths, how big it's going to be. So mold does not stop unless you take concrete actions to stop it. So here is something which I thought I will show at the risk of showing some graphs and all that, which I try to avoid, but I couldn't help showing this. What this tells you is, if you have got any of the moisture indicators, what is the likelihood of, you know, the allergies such as asthma, rhinitis, allergic rhinitis, and rhinosinusitis, conjunctivitis. What it says is, if you've got mold udder, if you enter a room and you find that there is mold udder, if normally you have a chance of 1 to get an infection, sorry, the chance of infection when you have mold udder, just you get the mold udder when you enter the room, the chance of getting the infection increases by 70%. It becomes 1.7. The chance of rhinitis, if it was 1, it now becomes 2.2, that is 120%, and so on. These are, graphs for various other indicators if there is dampness on the wall. So basically, what I'm trying to say is that when you enter a room and you find that there is mold odor or there is dampness or water damage, it's not just that it is a bad sight to see. It is a dangerous place to be in, and you should take actions to see to it that it is remedied. This problem is remedied. So you can't afford to live with this problem. Now, why does mold appear on the walls? Basically, it's more to do with, dew point and, these kind of terms. I showed that particular tumbler which is cold and, dew formation was there. Same thing happens with the air which is in contact with cold surface. So, what happens is there are two different things that happen in a room. One is the temperature in the room and the relative humidity of that. You can see the room has got 26 degrees and 60% relative humidity, and the air looks quite comfortable. But what is happening at the surface is the surface temperature could be 22 degrees centigrades and the surface humidity might be 60%. It much depends on how your airflow directions are. I'll show you in a subsequent slide. And the surface humidity is 90%. And the more the humidity, the more the chance of your mold formation. This is something that you might have encountered. You've got an airflow which actually partly hits the adjacent wall, and that's where it's colder than the room. And the surface humidity there is very high, and the mold starts growing. Now we come to the other part, that is the particles in the air. We have got the PM, that is particulate matter. You've got PM10, that is particulate matter 10 micron and above. This is the size of the particles. The thing about this particulate matter is it gets into our respiratory system, goes deep into our lungs, and starts causing infection. We have got PM 2.5, that means 2.5 micron and above. So basically, the smaller the particle, the more damage it can cause, because it goes deeper and deeper into your respiratory system and gets a chance to create infection in your lungs, and then thereafter into the bloodstream. Then you've got PM1, that is 1 micron and above. And then today we are now talking of nanoparticles, that means which go far beyond PM1. And the latest is particles which have got gas molecules attached to them. So all these are things that are there in the air. This is the result of our modern living. These things are inevitable things that are there in the air. Apart from that, we have got gas pollution. We have got the CO, which is coming from combustion. Ozone, O3, then NOx, SOx. Basically, all these come from some, some fuel being burnt somewhere. Mostly, it's that only. VOCs are coming from your furnitures and other such sources. I'm sure you, as architects and indoor designers, would know quite a lot about it. Then there are other toxic hazards. And apart from that, there are microscopic organisms in the air, like endotoxins from pets, like cats and dogs, and vermin like mice. So basically, if you're not taking care of your pets, be sure that there is going to be endotoxin inside the area floating around. Then fungus, which I've already elaborated. So fungus, namely Aspergillus, Penicillium, and yeast from dampness. Then we have got gram-positive cocci. Basically, all human beings are shedding certain amount of their skin as skin flakes. So these skin flakes, in millions in number, are being released by each person every hour into the air. So if you've got a person having some sort of a disease which is manifest on the skin, you'll be breathing quite a lot of it. Then we have got gram-negative bacteria due to the presence of water indoors, and then we have got fecal bacteria due to heavy indoor air contamination from sewage. So this is one of the worst type of indoor air quality afflictions that you might have. Then we have got bacteria from respiratory airways through fuga droplets from talking, sneezing, and coughing. So basically, this got a lot of attention during the COVID times. So basically, when people especially laugh and talk loudly, they give out quite a spray of these small particles into the air, which hangs around in the air and it gets into people's respiratory system. So ultimately, we are really interested in what is the way out. So filtration is a way out. Basically, you've got polluted air, and the filter is expected to take care of the particulates, the gases, and the microbes. So basically, the filters, you may say, are the lungs of a building. Lungs are the filtration system of the human body. That's it. These are filters for the building. So if you see what is popularly used at office level or a residential level would be room air cleaners. So basically these are of various types. Inside the air cleaners, many types of filtration technologies might be packaged. It could be by ionization, it could be by activated carbon in it, or it could be by HEPA filter inside it. But the whole idea is to filter out these kind of impurities. Then there is upper room UVGI. UVGI is ultraviolet germicidal irradiation. Basically what happens is at the upper level of the room, uh, you have these rays going so that it doesn't make eye contact. So when you have these convections, heat convection from the lower level, it goes to the higher level. The bacteria, the pathogens which reach that level, they get neutralized. And this has been found to be extremely effective in especially places where, a lot of people sit, like reception rooms of dentists and, these doctors. So it's a very effective way of, remedying this particular problem. Then, of course, I mentioned about activated carbon. This takes care of smells and odors. So these are the types of commonly used filters. So the key takeaways of what I've just now told is that IEQ is how a building makes people feel when they breathe, sit, and live inside it. You have to control three things well. That is the air movement. You don't want stagnant air. You don't want moisture accumulation, and you want cleanliness. The other thing that you want is ventilation is not just how much air we supply. It is important where that air goes. That's your effectiveness of air distribution. Poor air distribution creates stagnant zones where CO2, moisture, and pollutants accumulate. Then we have moisture control is the most effective way to prevent mold growth. Filtration and air cleaning help remove particles, gases, and microbes. Good architecture plus good HVAC design equal to healthy, sustainable buildings. I think I've come to the end of my presentation. Thank you very much.
Thank you so much, sir, for that very informative session. If anybody has questions, they can put it in the chat box, or else we can move to the next session.
Lekha, I had a request that
Yes, sir.
I would be exiting early, so I might not be
Okay.
able to wait till the end. If it's possible, if it's okay for you, you can ask the questions right now.
Yes, if anybody, any participants have any questions, you can ask. Yes, sir, we have questions in the chat box. What is the best way to control at homes? Best way to control
I
at
couldn't read
homes.
that. What did you say?
Yeah. Yeah, I think Pinaki sir has a question.
Yeah, sir, thank you. My question is on your wonderful presentation. Thank you so much. Yes, basically
Thank you.
these are these solutions we perceive when we build hospitals or labs or buildings. But what do you suggest for residential homes? Because these are mainly done by again architects at a design stage. But what are the things as a customer, as a consumer, a home buyer, we should be discussing with architects to so that we can overcome these issues. Thank you so much. And thank you so much
Okay.
for the presentation, sir.
Uh, Mr. Pinaki, the thing is, fresh air is compulsory. Okay, let's face that fact. What happens is in polluted cities, people feel, if they open the windows, they'll get all polluted air. It's very much true. But if you're getting polluted air, you have to find a remedy for it. The remedy is not stopping the air, the remedy is filtering the air. So you have to have fresh air, without which you're going to have other bigger problems at hand, like your moisture buildup and many other things. You should have, some way of air cleaning if, dust is a major issue in wherever you are there. You know, suppose you have a residence and you've got an extremely polluted exterior. In that case, you may be well advised to use an air cleaner. That's now going to be a part and parcel of our modern living. Or if you're designing a clinic, in fact, ISHRE has just made a publication which is on small clinics. Where do you, even if you use an air cleaner, where do you place it? So that the air movement is such, it's very effective. You get the best possible effect from that particular air cleaner. Similarly, if, for example, where the doctor is sitting, which way the air direction should be, it should not be the patient's all respiration is coming into the doctor, and that poor doctor is getting that respiration of others day in and day out. The placement of all these devices, how you analyze the airflow, it is not something like a rocket science or something. It's explained in very simple terms. The whole idea is you should not be getting others respiration. Others respiration should get dispersed before the air comes to you. So there are 2 points that I've made. One is, of course, having filtration if the air is bad, and the second is the direction in which the air is flowing. So these are the 2 main things on which you'll have to concentrate if you're, trying to make your home a better place.
Hello, sir. Hello,
Any
sir.
other question?
Yeah, question is whenever we design like offices, conference room, uh, how can we decided the how much area required for how many people? Like once we design the building and we construct the conference room and offices, it may be somewhere some 10 people, 20 people are sitting for meetings and similar activities. On that time, before designing these things, we can design the ventilation area or ventilation part, or after design we can reconstruct, because after complete building design, maximum ventilation are not there because controlling the air conditioner and similar things are there. Then how can we ensure about if somewhere some 20 people, 30 people are sitting for some meetings, not for daily, for once in weekend or once in twice or in month. Then on that time, how can we calculate the available air quality is good for professionals or people those are sitting there?
Okay, a very good question indeed. What happens is, especially when people sit for long times in these kind of spaces, and these spaces were not designed for that particular application. I get that this is what you are suggesting. In a meeting room where normally few people are supposed to be there is a crowd of people sitting there, and they are there for hours on end during the weekend. So what happens is, one good way is to have a sort of, today you get these monitors. You don't need some advanced monitors. Even a CO2 monitor you can have. So if you find that the ppm is going far beyond 800, 900 ppm, it's time for people to take a break, take some good fresh air, and come back into the room. That's all I can suggest, because you've got nothing else that you can do in that room. You need fresh air. You might be having air cleaners. It's not going to help. It's going to help only to some extent. But without fresh air, without the oxygen, the CO2 buildup is going to be pretty high. So it's always good to from time to time have those breaks, and the breaks do a lot of wonder to your becoming fresh again and resuming. That's one way. And some people, some of the other recommendations are, you keep out the door open for some time. uh, Interrupt the meeting, keep the door open for some time, let it breathe some more air. So these are the measures that are to be applied on a rational basis. That's what I would suggest.
It means we have some automated ventilation system. Those are open frequently after time to come out fresh air from outside to inside.
I didn't quite understand that.
I mean, we have some automated ventilation system in the conference room, or some ventilated doors are there. Those are open frequently after time to time. Better to we
Yeah, that's
stop.
a very good thing to do. That's a good thing to do. See, for example, there are recommendations, for example, in restaurants and all that, where, it's become very stuffy, and there is no source of proper fresh air. So they should keep the, door open from time to time, and that frequency is also mentioned, so many minutes in an hour, you keep it open so that some fresh air from outside is coming. Otherwise, it's going to be really bad air inside.
Okay, thank you,
If you
sir.
want to automate it, of course, that's the next level.
Yeah, thank you, sir, for suggestions.
Do you have any other questions? I guess that's it,
I,
sir.
I think there are no more questions.
Right. So thank you so much for your session.
Thank you.
इतना सा है स्पेशल
So we move on to our next speaker, that is Mr. Vyomesh Mehta, Chief Engineering at Aura Engineering Solutions. Mr. Vyomesh Mehta is an entrepreneur with a background in aerospace engineering from Technan, Israel Institute of Technology. He has worked on multiple projects, including tunnel ventilation systems, dust control systems, atmospheric water generator systems, with strong emphasis on generating more output with novel designs with lower power consumptions. He heads the Aura Engineering Solutions, executing pan-India projects. His recent work includes development of Aura fresh air units designed for modular heat recovery solutions designed to provide fresh air with heat recovery in a decentralized manner. With focus on low power consumption and ease of maintainability, the product solves the problem of fresh air for indoors, a problem which is very widely close to heart right now. Today, he will be sharing practical perspectives on implementing ventilation systems and improving indoor environmental quality through his engineering solutions. Vyomesh, sir, the floor is yours. Thank you.
Thank you, Lekha, for lovely introduction. And thank you, Dr. Roshni, for setting up such a very important event of this type. And let me just start with my presentation. Share. I think is it visible now? Good. Am I audible?
Yes.
Yeah, okay. Yeah. So, I mean, as Mr. Gautam and Dr. Roshni mentioned about the importance of fresh air, I think I'll be repeating at the risk of repeating myself on the same topic. I would like to say that one of the problems which we face with high concentration of CO2 is that we don't see CO2 as a someone who's sitting inside a room, since we cannot see the CO2 or any VOCs or visual, there is no visual connect with the bad presence of air quality. So the symptoms like drowsiness or headache or any cognitive deficit that we encounter subsequently, we often think that probably I did not have enough, probably I didn't have good tea today, probably I'm too tired, probably I didn't have good enough sleep or something. We tend to attribute it to something else, and that's why the idea of having a bad air quality indoors, that too even after putting so much costly air conditioning solution, is something that doesn't really get into the common person's mind. I say. And then when we as Dr. Roshni was mentioning in the beginning, that when we interact with builders or architects and or let's say end users of a particular indoors, we encounter several feedback from them, which makes us think that this topic is not widely well known. Then and there are some myths that persist, that okay, if I have a split AC, I have enough fresh air. If I have centralized AC with ducting with cassette AC, yes, I have fresh air in my indoors. So when we say that, cassette ACs have provision for indoors, but I haven't seen a single contractor put up a fresh air pipe to cassette AC from outside. So once the end user starts getting more educated, and then they say, "Oh, sir, but we have so there is a problem of fresh air. We'll use air purifiers. We'll use air fresheners. We'll use this spray to avoid bad smell in there." So the, even the some of more experienced, let's say utility in charge of some of the management organizations, I have seen people argue that, oh, we have set up VRV system, we have set up VRF systems, it's most advanced system, so we must be getting good fresh air, right? Said, sir, you have just put up split cassette ACs. You have put up even your chiller plant only has fan coil units, and there is no fresh air supply or indoor. What are you saying, sir? We have put up such a large VRV system on top of our terrace. They must be bringing some fresh air. So these are common sort of scenarios that one encounters when we try to educate people about fresh air. And as Gautam sir was mentioning about the indoor air qualities, yes, our experience is, yes, the typical indoor office space carbon dioxide levels are always close to 2000 ppm, which would be one in every 20 to 24 breaths that we breathe. It would be someone else's exhaled breath. And the typical exposure up to 5 to 6 hours can give us a mild headache, and the symptoms are very close to having lived in a very stressful environment. So one needs to consider this very seriously, given the numbers that and amount of time that we spend indoors. One of the very dangerous manifestations of lack of awareness about space we can find in the case of in hospitals where individual rooms are given. The fellow is trying to recover and he's complaining to a doctor that I'm feeling a bit suffocated, sir. I'm opening my window. I'm getting all dust, I mean, the traffic pollution inside. So that's why I have to close them. But even though I'm feeling suffocated, the doctor, with say about 30 years of experience and quite quite a quite a gem of his field, comes to the patient. Sir, please use the split AC, sir. The AC, you're paying for the AC bill. No, you have to use it, sir. Feel free to use as much as you want. And then, and at the so it's not about, one doesn't really want to take steps about fresh air and air quality. It's just that the awareness is missing. Another practical manifestation is our kitchen. No, I'm sure not everyone here would like their food with some tadka and the spices. But given the most of our homes are not quite ventilated, let alone the kitchens. Nowadays, there is a trend that more kitchens are implementing kitchen chimneys, but even then, the kitchen has to be isolated. If the kitchen is not isolated, there is always a chance of spreading the, say, PM 2.5, PM 10, or even some formaldehydes, or and some aerosolized spices can spread across the rooms and settle down on furniture, and as the temperature permits, can rise in the air and can cause respiratory stresses. As someone who's myself who suffers from allergic rhinitis, I remember that whenever my mother has to cook or my wife has to cook something deep fried, I would be in a different room, or I would be out of the house. I would be happy breathing the traffic air pollution than oil vapors at my home. Oh, yeah, that's the part. So ASHRAE, as Sir was also referring to, ASHRAE 62 comes to our help in terms of how much quantum of air that you would require. So, all right, we have identified the problem, we understand its severity. Now we want to solve it. How do we go about it? Okay, so here is a point to start where the quantum of air is defined based on the let's say the environment that you are in, based on the square footage, and based on number of people that there are going to be inside. You measure the fresh air required, and also make sure that it's going to be properly circulated throughout the space, and and you work out a number that needs to be supplied. But there is a challenge that once we bring in the fresh air from outside, it can come with outdoor pollutants. Not always do we find that outdoor air is quite healthy, so we have to address that. And another point is when we are using ACs inside, comes with outdoor heat. So when you bring a lot of air with outdoor heat, your AC rarely gets to cut off mode and it's continuously running. So there is a stress, there is higher operating cost, and the life of AC also gets reduced after a very long period of time. So we need to address these 2 points. One is the pollutants, another is the heat. Vice versa, if you're heating the indoors, like in the place north of Delhi or places like that where you need heating inside during winter times, you need to address the coldness of the ambient air. Two ways we can address, as the field of filters is quite as it's an ocean of a field in and of itself. Like, can start with all kinds of filters can be used to address the outdoor air pollutants depending on what kind of indoor air quality we want. Subsequently, as far as the thermal imbalance is concerned, one can use heat recovery mechanism through different types of heat exchangers in a way that you utilize the indoor air and outdoor air, pass it through heat exchanger, see that there's some kind of economizing balance can be struck there. Now, now comes a third challenge. Uh, is that when we want to move a certain mass of air from one place to other, you cannot just move it in an open way because it get mixed with indoor air, and so here one has to move the indoor air to inside and also make sure that the indoor air uh, and vice versa, make sure that it's done in an efficient way. So here is a small graph. Uh, Please don't lose me over here. I just want you to focus it on qualitative aspect of it. Don't get too deep into the numbers. But so this is a graph showing that when we try to pass quantum of air through a diameter, say, of 2 inches or 3 inches, 4, 5, 6 inches diameter of these flow rates, say from 20 to 250 CFM flow rate, these are the typical velocities that we observe. Now, why is velocity important? Is because velocity, your pressure drops and the power that you would require to pass certain quantum of air is proportional to the square of velocity and cube of velocity. So higher the velocity you are going into, the power wise you are becoming more inefficient. And once if you go for lower velocities, you require higher volume to transport air, higher physical space. Let's say could be ducting, could be opening in the wall, could be opening, could be a machine or something that you would require larger and larger. And on one hand, you want efficient filtration, also want heat recovery, and you also want something that is not like a washing machine hanging outside your door, outside your room, or something like a washing machine hanging inside your room. So you want it to be compact as well. And when we speak with architects, architects don't want to even have a wall clock on their wall. They want everything. They don't even want to see fans. They don't want to see split ACs. They just want that very neat cladding. And you make it as tiny as possible, sir. Please, that's the request that we get from architects. So yes, one has to strike a balance between efficiency, the size, and the quantum of fresh air with filtration and heat recovery. So let me just put that picture into overall. Let me try to summarize this. So on one hand, we have natural ventilation where you're just moving air through open windows, open through stack effects, thermal balances. You optimize your indoor in a way that it's properly naturally ventilated. On the other side, it's a complete closed box where you don't have to open a single window, not a small crevice, not a single opening there, and you do ventilation through mechanical means. On the natural side, there is zero filtration. I mean, you cannot filter the naturally ventilated. Very, even if you do that, it will be very moderate filtration you can afford. There is no heat recovery, and it takes place with zero noise. On the natural side, you don't require any power as well. So there is no energy to move the air. It's just naturally that's taking place. But you require very large openings. You need to have openings, you need to put stacks, you need to put, so the volume and surface area that your ventilation provisions occupy would be very high. And the vice versa load on your air conditioning system because of natural ventilation would also be very high, which is a very counterproductive to all the, let's say, from green building perspective, it's a very high operative carbon, you can say. And on the mechanical side, we can go for as high filtration as we want. We can do, let's say, even 80 to 90% of heat recovery. But when we go for smaller size, if we want the system to occupy less size, we have to encounter with higher noise level because the velocities go high, your power consumption is also high. And then, so one has to strike let's say, a reasonable balance that any system that is provided to provide fresh air should uh, provide filtration, heat recovery in a way that doesn't make a lot of noise. The ventilation power. Let's say if you ask someone that in your home or in your office, if you have 3 to 4 rooms, per room, if I give you fresh air, would you be willing to spend around, let's say, 80 to 100 watts? People would say yes, probably. But say if you say I would spend 1 kilowatt, I'll make a very compact system, I'll spend 1 kilowatt per room. That would add a lot of pressure on the operating cost. So that's where the designer has to sit and strike a good balance. And now coming to our organization, where we have just a second. Yeah, we have tried to strike that balance by designing our decentralized heat recovery and fresh air units, where we provide fresh air through outdoors. As you can see, these are our units. We provide from one side we provide fresh air inside the room, and on the other side we suck the room air and throw it outside. And in the process, fresh air passes through filters, and there is a heat exchanger through which the outdoor air and indoor air pass through. And let's say, to give you an example, if indoor is 25, outdoor is 35, we get fresh air at around 27 to 28. So air conditioning, that heat recovery helps your air conditioning reduce the additional air conditioning load. And as you can see, our sizes are close to 750 to 1000 millimeters. And this is very close to a split AC units. And we take from, say, and yes, the very reason to go decentralized is to avoid ducting. And as much as possible, as you can see, we have to go for some moderate ducting in some installation cases where we cannot get access to outdoor air. We avoid ducting to minimize our maintenance cost, and let's say, and also not spend a lot of power in transporting air through the ducting. This is our little, let's say, if I may show you, this is how it, if one of our model in action looks like. This is the suction, where room air is getting sucked out. And this is where the fresh air enters after heat recovery. Yeah. So, yeah, another last point about the mixing and how the fresh air spreads around. When we were developing this, we did some smoke tests, and we have designed the grill sizes and flow rates are in such a way that there is no cross flow from supply air to the suction air. We check that with smoke test, and visually there is no presence of any cross flow. And whenever we install these, we make in an indoor, we make sure that there is enough, let's say a cassette unit or a split AC unit or even fans, as you can see here. Make sure that there is enough, even that the fresh air gets evenly spread across the space. So these are the points that I'm happy to highlight, and I thank you, RUAT, for that. Thank you.
Thank you, Vyomni sir, for your valuable insights. If anybody has any questions for Vyomni sir, you can put it in the chat box or you can ask.
Yes, ma'am.
So we have one question for you in the chat box from Sagar sir.
Could you? I'm trying to get to it. Second.
Sagar sir,
Okay.
you can ask your question.
Need to complete presentation filtered in direction which.
Hello, sir. Nice
Yes,
presentation. So just
thank you.
wanted to ask, is there any standards or handbook available for related to HVAC standards that we can follow in hospitals? Or the ASHRAE guidelines in this simple way that we can learn and use in our
Yes.
hospital today life? Yes.
Yes, I don't remember off the top of my head, but I think there are some clean room guidelines that you can follow, same guidelines for hospitals. And it, you have to take a call in terms of, mainly it's filters sensitive, and, and what kind of positive pressures. So basically, I don't remember the numbers for that. You have to have positive pressure. But if it's a contaminant room, I see you also want negative pressure so that there is no spread of the contaminant going outside. So yeah,
Okay, sir.
I'll
Thank
try
you.
to look at that. I see, yeah, I see the message. Thank you for such a wonderful and easy to comprehend presentation. Filtration and direction of which the air is following.
Sir, it's question. Sir, one question is there.
Yes,
In last video, we seen cross ventilation on same position. Like in same machine, one person showing inlet
yes.
air and outlet air, both are in same position. In that case, there is no meaning, na? You are taking air and you are throwing air on same
That-
corner. Then there is no meaning of cross ventilation, na? It's need to some distance from inlet and outlet air, na?
It's a very good question, sir. I'm sure you're referring to this particular video, right?
Yes, yes.
Yes, so in this device, so what I'm saying is, so we do a smoke test on these devices, okay? So let's say on outside, I put smoke and we see where the smoke is spreading, okay?
Okay.
The design of this grill on the right hand side, which supplies fresh air, the size is kept in a way that the velocity at which the air comes out, for it to go back inside, it has to travel all the way across the room and then come back. And that's why there is a distance between them. If I put say tufts or what do you call those, say some plastic bags or something, we check it with smoke and we also check with tufts where the airflow direction is there across the room. And do you follow me, sir, with the smoke test example? Hello?
Yes, please.
Yes. So when the smoke is coming in, the smoke does not right away go in the suction side. It goes, spreads across the room, and then it comes back. And that's why
But
you see that there is some distance between both the grills, and the distance is critical, and the velocity at which the suction is taking place and the delivery is taking place. Both of them are to be in balance.
sir, you are correct. But if we put both the instrument in crossway direction, like in opposite direction or in opposite wall, it's better result because it will collect more air from its inside or outside.
You mean to say supply on one wall and the delivery on another wall, right?
Yeah. Yes, sir.
In
Yes,
that
sir.
case, in that case, you'll have to put ducts for heat recovery, right? So to do the heat recovery part, you have to have a heat exchanger where you have room air as well as the outdoor air passing through the heat exchanger, right?
Yeah.
If you don't have heat recovery, what happens is that you get hot air inside, regardless. Let's say you put even the best of HEPA filters, you get hot air, right? And
Right.
the thermal load is going to get transferred to your AC.
It may be. It
To
may be.
well, if not AC, then where else, right? So the distance between these two grills and the size of the grills is such a way that there is no cross flow. And the proof, I tell you the proof of the pudding in this. Let's say I have a room that is 2100 ppm, okay? As we can see in many, which is the many of the case in these installation, we see 2100 ppm, your ambient is 400 ppm carbon dioxide. Once we install this, we see that the room is at 450 ppm, regardless of where you put your sensor. Would you say that is it giving enough distribution?
Yeah, but it means the size of the filter is depend upon the area of the conference room or hall or
Not
cabin.
filter. No, size of my unit would depend on what capacity is required. Suppose I
Yeah.
need higher capacity, I can install more of these, right? Yes,
Okay.
yes.
Okay. Thank you. Thank you,
Thank
sir.
you, sir. Thank you. Thank you. Yes, okay. There is
You have
another one.
any?
I just want to ask how we can better
No, that
understand
was
that.
the
Ah,
one who
okay.
had asked. Do we have any other
Okay.
questions for Vyomesh, sir? No, I guess that's it. Thank you so much for your session, sir. So, our final speaker for today is Mr. Abhinav Gupta. He is the founder and CEO of Breather. He is a graduate from BITS Pilani, EPFL Switzerland, and NUS Singapore. He works on improving indoor air quality through data-driven monitoring and smart building solutions using sensors and building solutions and smart building solutions using sensors and analytics to track parameters such as particulate matter, CO2, humidity, and other pollutants. Breather focuses on advanced indoor air quality monitoring and smart ventilation solutions to help buildings better understand and manage the air people breathe indoors. So, Abhinav sir, over to you.
Thank you so much. I'm just going to present my screen. Just give me 1 second. Yeah, thank you so much for having me here, everyone, and really great sessions by Vyomesh and Gautam sir in the beginning. And as Vyomesh also mentioned, I think a lot of the stuff has already been talked about. So I will try to keep this short, and I will try to keep it precise to indoor air quality monitoring. Even though we do a lot of stuff around solutions as well, but my focus today is primarily going to be around indoor air quality monitoring. I hope everyone can see my screen. It's visible?
Yes, sir, it's visible.
Okay, awesome. Yes, so yeah, I mean, I think a lot of people in the world already know about this, and even in today's conversation, both the sessions talked increasingly about talking about CO2 ppm and talking about how many breaths that we take are someone else's breath. And I mean, it's not that's the thing. It's not a new phenomena. We already knew about it in different ways and forms. We used to call it, suffocation, dum ghotrai, it's stuffy, all these, we had all these like adjectives to describe what the air felt like, but we never really knew what was the cause. We knew that it was bad. And the comics across the world have talked about this. This is a very famous comic from XKCD, maybe 10 years old. It's not a new comic. And we all know Dilbert. Dilbert's a very famous comic. Again, this is a comic from almost 15 years old. And it talks about not just air quality, but the broader topic that we are talking today, indoor environment quality. So air quality obviously includes your CO2, temperature, humidity, PM10, PM2.5, VOCs, ozone, NOx, SOx, the list is never ending. But when we talk about environment quality, in addition to all the things that are air, we also talk about water quality. Ishre talks a lot about water quality. We talk about light, something that is also not touched upon very often and very important. Good lighting, sunlight, daylighting, the amount of lux needed to do work in different environments, very, very, very important and often very times neglected. And on the other side, you also have sound, or uneven cooling, uneven heating, not enough fresh air, smells bad, all these other things. So we know that this problem exists. And quickly to touch upon the things that already people have spoken about, it's a silent killer. There's a constant exposure. There's a health risk, and as Ramesh sir mentioned, the solutions are fragmented. We talk about VRV. I've had people who are graduates from IIT come and tell me, "Arey, but AC hai, to fresh air aa hi raha hoga." But that's not true. The AC does only cooling. It does not do fresh air. The fresh air system does only fresh air. It doesn't do anything else. The standalone filters, they just filter the air. They are not working on fresh air ventilation or anything else. So the solutions are fragmented. We're constantly exposed to air. 15,000 liters of air we breathe in a day. We drink 3 liters of water, maybe 4 liters of water, but 15,000 liters of air we are breathing in a day, and it's just very casual for us. We don't think too much about it. More importantly, I think if you imagine your life in 80s, early 90s, you would probably spend 60% of your time indoors. 40% would be outdoors. But now we spend roughly 93% of our time indoors. Even our gyms, our swimming pools have become indoors. So many of the activities that we do are kind of semi-indoors or indoors. I have started to see international schools having football and cricket kind of playgrounds indoors. So I believe that in the next decade, in the next 10 years, 15% of our population will spend 100% of their time indoors, because outdoor air quality, temperature, it's rainy, it's stuffy, it's cold, it's hot, it's going to be too much. So we're going to spend more time indoors, and we are going to be not breathing any fresh air. We're going to be breathing only indoor air. Some numbers to touch upon. I think a lot of people did talk about, on an average 2000 ppm. I have been monitoring air quality for over 11 years. I have seen some numbers that are not at all uh, close to 2000. I have seen numbers. I think we will go deeper into the limitations of the sensors themselves, but any good, decent air quality monitor that monitors CO2 should be able to monitor up to 5000 ppm. I have been into a bank, an ICICI or a SBI, one of these big banks, a branch office on a Monday or a Tuesday where the bank is completely filled. And I just took out my air quality monitor. It stayed at 5000 consistently, which means that the sensor wanted to measure more than 5000, but it wouldn't be accurate. The number wouldn't be accurate. Even here, the 6981 number, it looks like it's a very high number, but the number can be anywhere between 15 to 20% in terms of its accuracy, because these are not accurate above 5000 ppm. Having said that, with very high accuracy sensors, we've been able to look at gyms. Any gym you take today, 4500 ppm of CO2. If you feel you are having pains in your body, or you're feeling lethargic, or you're feeling headache, or you're getting nausea, or just chakkar aa rahe hain. In fact, so many times we also hear that someone very healthy has gone to the gym and they're like, oh, I'm not able to breathe. That's primarily because of very high amounts of CO2, close to 4500, where a coal mine has 7000 ppm. So today's gyms are effectively sending people into coal mines and asking them to lift weights, which it's horrible. It should not happen. It causes not only like cognitive skills, but also has a severe impact on cardiac health. Right, so I'll just touch upon a little bit on breather before jumping completely into air quality. But basically, this is the problem. After 11 years of monitoring, what we have started to build is a combined unit that gives fresh air, it gives temperature control, it gives oxygen, it gives filtration, single digit AQI, all in a single device, right? However, I will not spend a lot of time on it, because that's not the mandate of my talk today specifically. I'm here to spread the word about monitoring. And despite having left the monitoring business, I believe that no solution in the world can be installed or should be installed without any kind of monitoring. Because as simple as it's like this: when you have a fever, you take the temperature regularly. You see if it is 104, you go and get different medication. You get 99, you do different medication. You don't put a wet cloth on someone's forehead when the temperature is 99.7, right? That is exactly why if the very golden saying in the industry is that you cannot manage what you cannot monitor, right? And I mean, despite this, there is no monitoring. I would say that only very few buildings in the world are actually monitoring. I'm not just even talking about India, I'm talking about the world. In the world, very few buildings are actually monitoring their air quality, because it is considered as a cost. It is considered as a kharcha ho raha hai, like it is adding to my billing. But I don't think what people understand is that any rupee you spend on the air quality monitoring is going to come back fivefold or maybe tenfold in better productivity, lesser absenteeism, and better comfort and better quality of work for the employees. Not just employees, but in a retail setting, it is better for your consumers. They will spend more time in the mall. They will spend more time in the pantaloons if the air quality is great. If you can advertise in the gym, or you can advertise that the air quality, it's better to work or be here than be outside or be in your home, people will spend time. So that monitoring will come back to you tenfold. So do invest in monitoring. That's the main part of what I'm about to talk in my conversation. So along with this golden saying, there are guidelines made by ISHRE, made by WELL, IGBC, USGBC, LEED, BREEAMS. Every standard in the world has defined what do you need to monitor, how often do you need to monitor, and what all are the limitations of what you're monitoring, like what is the standard and how much it should be and what are the points. Now the thing is that these guidelines were designed for everybody. So they would say that it is recommended to do 24/7 monitoring, but if you can't do 24/7 monitoring, then do a spot test. Do one test, do test before and do test after, right? So now what happens in India is that everyone is thinking about acha test है ना, test pass karana hai. Okay. So you will give money to the air quality monitoring. It's like change the readings. Give me readings that I pass. This has happened. This happens very often. Or the other side is that they are like, okay, you monitor at a time when we know that the air quality, that the CO2 is going to be less. So, but 6 baje you monitor. There is no one in the office. So the CO2 obviously is going to be fine. But in this large segment of people, there are a few segment of people, and obviously the forum created here are filled with people who do this kind of a thing, where they are like, no, I want to monitor it properly, and I want to use the data of monitoring to actually improve the air quality. And with Roshni ma'am, with Kashyap sir, and the folks here in the conversation today, I have done this for the last 10 years with this set of people, where the intent is actually to monitor, to analyze what is happening, and then use the analysis and insights to then actually do something very precise and concise and then solve the problem almost surgically, right? So how do we do this? To do this, monitoring has to be done 24/7, 365. It cannot be not monitored at any time. Why? I'll give you an example. So we did this building a premium public bank company. The entire building is theirs, and we would be monitoring the air quality for 1 week, 24/7. 1 week, 7 days, 24/7, we would monitor the air quality. Now, on a Monday, the CO2 would go up to 3000 ppm. Monday, around 1 p.m. 3000 ppm it reaches. And then Tuesday at 3 a.m., it would reach to 500. Then on Tuesday, it would go to 4000 ppm. And then Wednesday, early morning, 3 a.m., it would reach 600. Basically, the building envelope was so tight that the CO2 could not escape. So on a Monday, the CO2 would be probably at 3000, but on a Friday, the peak CO2 goes up to 5000. Not because there are more people, but the buildup of CO2 that happens in the building is just completely caught up in the building envelope. And the building envelope is made very strong because it is insulated, it has to be best for cooling. Great, but there is no ventilation. So there is no ventilation. The insulated building is only going to capture all the CO2 inside. Now, CO2 also has a slightly higher specific heat capacity than normal air, which means that effectively you are spending 5% more energy on a Friday than on a Monday to cool the air because of the CO2 buildup. Now, this kind of insight you cannot get without monitoring 24/7, 365. You cannot do spot test on 2 days, 3 days, 4 days and get the data. You need to get the complete trend and then analyze the trend to understand insights. And then on the basis of those insights, you will be able to solve what air quality problem that space is facing. Now, uh, now that we've covered the guidelines, just ISHRE, WELL, all of that, the question that I get very often, and especially when I was running my own air quality monitoring business, is that what kind of monitor should we use? Now someone will come and tell me that, oh, there is this Chinese brand, 1,000 rupees, IKEA, 2,000 rupees. And then there's this American brand, 70,000 rupees. It's like your sensors, 50,000 rupees. It's like, why should I buy 50, 70,000 rupee sensors? 1,000 rupee sensor is there, I will buy that. Now, inherently, everyone who is smart enough will know that the quality of data coming from 1,000 sensor and 70,000 sensor is going to be very different. But they don't understand the magnitude of the difference. They think the magnitude is very small and the 70,000 guy is just trying to make money. That's the understanding. And it is not wrong. I mean, I don't blame when people make such decisions because they are not equipped with the right information, right? So, and today, after air quality has become such a big problem globally, there are more than 1,000 brands available. So then which one to use? And for exactly this thing, there is a certification that came about, I think around 2017, and now it has spent maybe 9 years in the business. It's called Reset certification. So Reset certification is a global certification body for air quality monitors only. I mean, they also do building certification, but that is not important. I mean, that is, I'll come to that, but that is not that important. I'm purely talking about Reset as a accreditation body for air quality monitors. And my company, the company that I used to work in and I used to sell air quality monitors, that company was one of the first 13 companies to get certified in 2019. Now there are more than 100 brands on their website which are accredited, and they've given the certification, they've given it a grade. Is it a grade A sensor, which is for scientific monitoring? Is it a grade B sensor, which is for commercial building monitoring? Or is it a grade C sensor, which is for consumer grade monitoring? So you can go onto their website, look at the directory, the database of all these sensors, and then make the right choice basis the cost, basis all these other things that can be there. So just a quick screenshot of their list. So this is the list. Now I have here worked with all of these sensors. My own sensor, active building sensor, is mentioned at the top right corner. This was the previous company where I used to sell air quality monitoring products. And the rest of the Airveda is also a Delhi-based brand, also certified by this thing. And they also show you how many projects it's been used in. But again, we are not much more interested in Reset projects as we are interested in the accreditation of air quality monitoring. In my experience, if I pick any sensor from this list, this is only a part of the list. The list is with, as I said, with 100 sensors. This is just the screenshot where I could see 2 Indian sensors, so I decided to put this one. But you can pick out any device from this list, and I can guarantee you that the data that is there is 5 to 7% accuracy threshold. So that comes to the second part, which is what kind of monitor to use. A little interesting thing here is the certified projects in India, which are Reset certified. So M. Moser's lab in Mumbai is the place where our air quality sensors are used. Just for your reference for everybody. So this kind of brings me to the end of my presentation, and I'm happy to answer any questions that come up. But the key takeaways are: monitor using the best possible sensing products. There is no point in buying a cheap sensor because it will almost always bring some kind of error into your analysis, because the reading is not at all close to what reality is, which is why your insights are not close to what reality is, which is why your actions will not be aligned in what reality is. So the monitor has to be the best possible product, which is a good Reset certified sensor. And in the beginning itself, account for the cost of good monitoring. Do not let it be a part of budget related issue. I have seen many excellent projects go down because like we did not account for a good monitor, right? The second is monitor 24/7, 365. Spot monitoring, you want to pass a test, you want to clear some certification, fine. But if you're looking to actually create an impact on the design or a retrofit, then spot monitoring is as good as no monitoring. Monitor 24/7, 365, or else don't monitor at all. Don't even bother. Go with insight. Go with qualitative analysis of people. and analyze the trends of the data. Always just look at, what is happening. For example, CO2 goes up, VOCs go up, CO2 goes up when people walk. So you can know that acha 9 a.m. people start walking is because you can see the CO2 go up. Okay. And VOC. So VOC sometimes, many times coincide with cleaning activity. So while CO2 increases at 9 a.m., VOC will increase at 7 a.m. because that's when the cleaning staff comes in to clean the place, to do jhadu pocha, whatever, use phenyl or whatever, and that causes the VOC to increase. Then at 9 a.m., people start coming in. Then people start going for lunch or whatever. I mean, you can analyze based on what activity is happening in the office, overlaid with this 24/7, 365 data that you have. And then with that, you will be able to identify. In fact, doing this, we were able to identify that one of the conference rooms had a table which was brought from some XYZ place. And the glue was so bad, the formaldehyde levels were so bad, and they were only bad when the meeting room darwaza was closed. The moment it is closed, it used to go very high. The moment you used to open, it used to go very low. So the emitting of formaldehyde from that glue or whatever was used, or varnish was used in the on the table, conference table, was so high that the complaint that people walked in was like, the client that walked in for us was like, hey, when people go into the conference room, they start getting this very strong itching in their eyes and ears. So immediately, as someone who's monitored air quality, would be like, okay, that's formaldehyde. 100% this is formaldehyde. But then you go, you monitor, you identify the trend. You can't just say formaldehyde hai. फिर वो पूछेंगे कहाँ से आ रहा है formaldehyde. Then you can't just like blame on anything. Like your data with the analysis will be able to say, okay, this is this table that is causing formaldehyde. So then you decide, either you throw the table, get a new table, or you figure out what to do with the formaldehyde. So that's my key takeaways. Why monitoring is important. Of course, solutions and everything are extremely important, but solutions are step two. Step three, in fact. Step one is to monitor. Step two is to analyze the monitoring. If you're doing step three without step one and step two, you're most likely wasting the money on the solution, with probably a 50-50 chance that it work or it doesn't work. Yeah. So that's it. That's the end of my presentation. Thank you so much for your time. Happy to answer any questions, and yeah.
Thank you so much for your engaging presentation, sir. We have some questions for you already in the chat box.
Okay. Yes. So, okay. I think the first question is, how can AI integration systems improve the monitoring and management of indoor air quality? I think AI integration will be very good in identifying the trends. So a lot of time we don't have the time to analyze large swaths of data, large batches of data. And to do that, I think AI is a very good tool. So you take the data of like an entire year, dump it onto the AI, and ask for its insights on when the CO2 was high. You can ask it very specific questions. So AI integration, I think it's going to take some time. I think it's not, I don't think it's there yet, because you will have to create your own prompts. You will have to, do trial and error on what works, what doesn't work. Or you can just make like an Excel sheet, generate an Excel sheet calculator using AI, where you just have to dump all the data and then it does all the calculations that you want. So for the step two, I think AI integration is going to be very interesting. The other question that I have is the Dragger make sensors reset certified? So I am not sure about that, but what I'm going to do is I'm going to give the reset accreditation list here. Um, you know, just one second. I'm just going to find the monitors directory, and I am going to just put it up on the chat. So everyone can look into it. You just have to click this link and you will see the entire list of the reset accredited sensors. So you can then find if your brand Dragger is there or no. But I think it should help.
इसका फोटो ही लेके आए sir
Yes.
one question is there, in our office, we are using only in 9 to 6, and other than its complete backend, there is no any person are there. So why we monitor 24/7? If you start monitoring from early morning and it will up to late night, then it's okay now. There is no concern. Only we are using 9 to 6.
Okay, I will ask you a counter question. Do you
Yeah,
have CCTV cameras in your office?
yeah, sure.
Do you do them only 9 to 6 and not monitor them from 6 to 9?
There anything is happening, so CCTV is required. But early morning when cleaner are coming in offices and they are start cleaning, we will
Yeah.
start early morning 6 a.m. It will stop up to 9 p.m. on. After that, complete system is closed. There is no any person entertaining
You don't
inside
know
of
that. You don't know that. I would apologize. I apologize, but I think you are assuming a lot of things here.
the.
This is assuming that your outdoor environment is great. I'll give you an example of a data center in Malad, which is close to the creek. I think there is a water body in Malad West, close to Infinity 2 Mall. Their complaint was our servers get corroded. Their servers were getting corroded at 2 a.m. because of some activity, whatever dumping or whatever was happening. We don't know what the outdoor activity is. But the outdoor activity causes NOx, SOx to rise outside. NOx, SOx get inside the system. NOx, SOx are now corroding the server. And that is happening at 2 a.m., 3 a.m. Similar thing used to happen in a school. There's an international school in Bandra. They used to have very high ozone or very high NOx, SOx, formaldehyde, VOC related trends. Very high, as in very high. Like I'm talking about like 10 ppm of ozone. Like kids were literally like coughing when they enter in the morning at 7 a.m. Now, all of this activity was happening when people were burning at a nearby garbage dump at 2 a.m. All the ozone was getting accumulated inside the building. So if I'm not monitoring at 6 to 9, I will not be able to catch that. So it really depends on your context. And my other question is, what are you trying to save by not monitoring from 6 to 9?
Sir,
Electricity?
sir, your example are very crowded area like Bandra and Malad. These are highly dense pollution. In
Sir,
fact, like
Bombay is fully crowded. There is no
yeah,
part of
yeah.
India that is not crowded.
But I am discussing about we are in remote. We are there is no such high dense population are inside of our nearby our factories. So I
Yeah,
am discussing only about our factory premises.
yeah. No,
Here
so
very
even
less
factory premises. Again,
population are
see,
there.
the point is that there are two things here. One is, do I absolutely need to monitor 6 to 9? The
Yeah.
answer is you might miss 2 or 3% of the cases that are causing some kind of air quality problem.
Okay.
Is your Then the second question is the cost of monitoring that high that I will let go of the 2-3% corner cases that I will not detect? Is the cost of monitoring that high? Electricity or whatever is the cost? इतना खर्चा हो रहा है कि that we should not monitor only. If the answer is yes, don't monitor. If the
No, no,
answer
sir.
is no, then
Sir,
that's up
money
to
is
you.
not matter. Money is not matter. Only my question is according to our uses. Money is not matter.
So then why not monitor? What are you losing out of monitoring 6 to 9? That's my counter question. It's fine if you don't want to monitor. That's okay. But I'm saying, what are you gaining? You're gaining the corner 2-3% cases that will be detected. If you're monitoring in the evening time, those will be detected. If you don't monitor, they won't be detected. So that's the downside. So what is the upside and downside of not monitoring? Money is one. What is the other? If they're monitoring and sending data automatically, server pe sab kuch kar raha hai, you don't need to touch it at all. Which is like your electricity meter, right? Why is electricity meter start at night? There's nothing happening. Electricity meter bhi band kar do. So ऐसे that question is not the right question from the context of is it important or no. I think the right question is from the business objectives. Does my business objective require me to monitor at night? If the answer is no, then don't monitor. As simple as that.
Okay, thank you, sir.
Thank you.
Do you have any more questions for anybody? Roshni ma'am, Ramesh sir and Abhinav sir are here. One question is, sir, what can be done to the existing buildings to like how can we incorporate fresh air into existing buildings?
For me, or
Anybody?
I mean, like I would suggest like we have.
Without doing a lot of retrofit.
I mean, see, right.
Because cost is a very big
Yeah.
issue.
Yeah. So I think retrofit is the only way. I think as Gautam sir also mentioned, if you want fresh air, there's no other way. You have to get fresh air. There has to be some way to get fresh air. And a retrofit usually in such cases is the easiest option. But in whatever retrofit you do, even if you don't do a retrofit, you need some point in the building where the air is being pulled in from outside. Otherwise, there is no fresh air. So you will in existing buildings, you will have to create some kind of provision where air is being pulled in from outside. Now, is it being filtered, not filtered? Is it being treated, not treated is a different thing. But just in some cases, just putting like a fan, like one fan on like one of the exhausts that is sucking in air, and on the other side of the building, so that pushes out air, so that there is like a cross ventilation, forced cross ventilation. See, that's the other thing. A lot of people say that if suppose we just open two windows, I'll get cross ventilation. But there's no breeze. And I'm talking especially in the cities, okay? I'm not talking about like remote locations. In the cities and like city like Bombay, where like high rises everywhere. If you are in Lower Parel, okay, you are surrounded by high rises everywhere. You open both the windows. There's no air flowing. So it won't matter. What we say is that in such cases, in some cases, it's better to force ventilation. And you do that by putting two exhaust fans or like one fan that pushes air inside and one that exhausts. That is the easiest way to get fresh air. Is what I believe. The other is obviously like, we have a lot of fresh air filtration products out there. Breather is one of them for sure. They can be used. But retrofit ke bina nahi hoga. You will need some kind of retrofitting to be done.
Okay. Thank you, sir. Thank you so much. So any more questions do we have for the speakers? Yes, I guess that's it. So thank you to all our speakers for sharing their expertise and valuable insights today. We began the session with Dr. Roshni Udayawar-Yehuda's presentation, who highlighted the growing importance of indoor air environmental quality and fresh air ventilation in modern buildings. She emphasized that the sustainable design today must prioritize human health, comfort, well-being, and as we spend a significant amount of time indoors, we need to take care of it. Our expert speaker, Gautam Baliga, shared valuable insights on fresh air ventilation strategies and how can we incorporate it into our buildings. And that plays a crucial role in maintaining the healthy indoor environments while ensuring energy efficiency. Then we heard from Mr. Vyomesh Mehta from Aura Engineering Solutions, who shared his practical perspectives on implementing ventilation systems in our real projects and how engineering solutions can support better indoor air quality. And finally, Abhinav sir from Breather introduced technology-driven monitoring indoor air quality devices, highlighting how sensors and smart solutions can help building track and maintain healthier indoor environments. We really hope this whole session has helped everyone understand the importance of fresh air ventilation and indoor air environmental quality in creating healthier buildings. Big thank you to all the participants today who has joined us and for your thoughtful questions also. So if you would like to learn more about sustainable building design strategies, please stay connected with RUA Ecospaces LLP. We look forward to seeing you in other knowledge series sessions which we bring forward. So I am putting a feedback form in the chat. I really hope you fill that and let us know if you have any inputs from your side. Thank you so much, everybody.
Thank you.
Thank you.
I've put the form link. You can copy that and you can fill it up and let us know if at all anything from your side. Thank you.